All right, hello everyone, this is Mr. Crozier. I'm going to go over review worksheet 2. I have the answers posted, but I want to just give you some help with it. Problem number 1, it asks for critical points. And remember, critical points could be maxes or mins. It's where something changes in the graph. And if you look at this graph here, the place that you have critical points are where the derivative is equal to 0 or undefined. So wherever this derivative is 0 or undefined, you have a critical point. So I took this function, took the derivative, e to the x is e to the x, with the chain rule behind it. And now this will never be 0 because it's an exponential function. This can be 0 at -1. So something critical happens at this point in the graph, possibly. All right, number 2, it's a area problem, top minus bottom from P to Q. You don't have to do anything, you just write it out. Number 3 says find the area from -5 to 3. Well, that's all of this area and then all of this area. But remember, the areas below the axis are negative and above it's positive. And these are all geometric shapes. So however you break it up and piece it together, there's more negative area than positive area. It's a -6.5. Problem 4, a little tricky until you just treat it like a u substitution problem, and this is the derivative of ln of u with u being root x. We have a function inside of another function. The derivative of ln of u is just 1 over that, so 1 over this, times the derivative of the inside, and there's the work for the derivative of the inside. So you have to do the chain rule here. If you can do the chain rule in your head, wonderful. If you can't do the chain rule in your head, do the u substitution. Number 5, just simply take the derivative. Be careful. Remember, we're taking derivatives. We are multiplying this down and then subtracting. If we're doing integration, we're adding and dividing. So you have those two differences there. You multiply this down and subtract it, but if you're going backwards, you add and divide. Problem 6, a function is twice differentiable, meaning there's two derivatives, and h of 8 is 5, so at 8 there's 0.5. The tangent, that's what that means, the tangent out of 8 is 0, so there's 0. And this right here is the second derivative is positive. If the second derivative is positive, that means the cup is facing up. If the second derivative is negative, that means the cup is facing down. Speeding up, slowing down. So that's what the second derivative helps you do. This one right here is kind of tough to do without a calculator, but it's a matter of u substitution. I let u equal this, which makes my integration so I can work it out. And then here I did f of 29 and f of 2 to solve it. A lot of work with fractions there. Number 8. This is a huge fundamental theorem of calculus problem. Please make sure you understand problem number 8. It's a huge problem to understand. If we integrate this, the fundamental theorem of calculus says we do the h value of the top limit minus the h value of the lower limit. Well, what is the h function? They give you the h function. A lot of problems that we did in class, you had to find the function. You don't have to find it. It's right there. You don't have to integrate this. It's already been done for you. Number 9, you can graph them, see which one's on top, integrate it from 1 to 3, fundamental theorem of calculus. And again, what did we do right here? F of 3 minus f of 1 of that function. We had to integrate this function. Up here, it was done for us. This is one you want to memorize. If it's dy dt and it has a y over there, and you do that work, you separate the variables, integrate them, you get to this right here. And it really will have a k right there. That's where the k will be. But in this case, it turns into the starting value is a c. So this is a k right here. And that k, sorry, it doesn't go there, it goes up to the top. But just memorize that this function goes here. I guess the best way to memorize it would be dy over dx equals ky turns into y c e to the kx. That number goes up and the starting value goes down there. It's just a memorization. There's a lot of work to that, but you want to memorize these functions where the chain dy dx is equal to y right there. Memorize that. Right here, take the derivative. I split it up into two parts and then took the derivative, plugged in 3. Number 12, I could take this right here, and the square root of 5 is the square root of 5, and the square root of x squared is the absolute value of x. If you square something and then take the absolute value of it, it equals the absolute value of x. So that's the absolute value right there, because that's going to turn that infinity positive. Those will divide out, and you'll have root 5 over 2. Again, here's critical points. What makes this 0? 7, 5, 3. Those are critical points like we did in problem number 1. And now if I do the derivative test using this function right here, it's negative, 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 which is down. Negative, positive, positive, or negative, negative, positive, up. And you have a minimum there and a minimum there. Again, absolute value, that's a critical point. Well, when is the derivative 0? 3. So the absolute maximum will occur at that critical point or at one of the endpoints of the interval. That's where the absolute value happens. All right, and you just plug them in to the original and test it. To get critical points, derivatives equal to 0. To get values, plug them in there. What's the value of derivative of tangent? Secant squared. 3 pi over 4. Know your unit circle. Comes out to be 2. Number 6. Again, we're going from negative 5 to 3 because the 3 goes there. Negative 5 to 3. Geometric shapes. 1, 2, 3. I piece them together. And area of 31. Second derivative. Take the derivative twice. Here's a particle. Let's do the position first. At time 0, it's at 3. At time 2, it's at negative 17. That means it moved left. It's talking about the x-axis. Usually we think of it up and down, but we can think of it side to side. It went from 3, if I drew an axis, here's 0. It went from 3 to negative 17. It went to the left, and the velocity is the second derivative. Make sure this is always in the back of your mind. Position, velocity, acceleration. You take the derivatives going down, you integrate going up. Average value from positive 1 to 4, it's 1 over 3 of that function. If you integrate that, you're back to the natural log function, ln of 4 over 3, because that's going to be f of 4 minus f of 1. 20, direct substitution. You can plug that in. That's the derivative. It is continuous at that point, so we're good. Integrate, integrate, integrate all the way here. Same deal here. 1 over x integrated its natural log. Same exact thing right there. These values, g of negative 2, well, at this point, it is above the axis. It's positive. This is position, velocity, acceleration. At g of 3 right here, the tangent is going up. It's going up, increasing. And g second prime of negative 3, that one, well, that one is slowing down. It's cup down. The cup down is right there. It's slowing down. So it's above the axis. It's going positive direction, but it's slowing down at that point. 23, FOIL them and integrate. This is nothing more than slope. This is a problem you could have done in your algebra class. y2 minus y1 over x2 minus x1 over that interval. It's a slope problem. This is a slope problem here at the point 5. You should be able to see this and write that. You see this function and you write this. The function is 2x cubed. 2x cubed minus 2x cubed divided by h at the point of 5. That is the difference quotient. Take the derivative, plug in 5, you're done. 26, you're going to have to divide this. Divide it out. Long division comes up with this quotient and remainder. Then you can integrate them all piece by piece. And 27, well, if this gets flipped over this axis, it is a bunch of washers. Outer radius minus inner radius. And I put the 0 on here just because that's the axis of rotation. That's where this radius is dropping. There's my two radius, big radius, little radius. They're both dropping down to 0. And you should have derivative of tangent memorized. Left, d right, plus right, d left. All right, the answers are in your copy. I hope this helps. Keep studying for the AP, and you will do fine.